Good evening, all. Today we are going to discuss about preparation of primary amines. Actually, so in this preparation of primary amine, we have a method called Hoffman's bromamide reaction. In this reaction, we are taking amide actually, amide, and it is treating with a strong base like KOH or NaOH and bromine. It gives rise to primary amine and metal bromide and metal hypobromide and water. So let's see the reaction mechanism. Now see in this reaction, first let me take about reactants. Here we have this R, C double bond O, and here we have H2. This is an amide group, right? So we know very well. Here we have R, C double bond O. This is functional group of amide actually. C O. Okay, this is amide, right? And along with that, we are treating this amide with sodium hydroxide, or we can say potassium hydroxide, and bromine. So it gives rise to primary amine RNH2 and NaBr and sodium carbonate Na2CO3 plus H2. Okay. So now let me see the reaction mechanism. Now see, this case where our amine will be there. First it undergoes, so it have two, sorry, yes, a second. Here we have nitrogen, and this nitrogen have a two hydrogens, and this will be when we are adding strong base. Okay, this will be an have a two lone base, and this will be attack here. It will attack this proton, so this will be shifted here. So now we get a result of amide ion here. So carbon double bond, nitrogen, and we have a negative charge along with one hydrogen. Okay, so this will be now R C double bond O, and this nitrogen having negative charge, and this hydrogen. Okay, this will be act like a electrophile or a nucleophile. Here we have bromine molecule actually. This bromine molecule, it will attack this bromine, so that this electron will be shifted upon this bromine. So now we'll get R carbon double bond O, nitrogen becomes NBr. This will be an hydrogen here, and the plus will get Br minus. Okay. So now again let me write our reactant RC double bond O, and we have nitrogen. We have Br, and we have here hydrogen. Okay. Again one more OH will be added here, strong as we have strong alkali. Okay. So now here again this will be tag this proton. Again it is under one more time deprotonation. Deprotonation if you want to see RC double bond O. Here we have nitrogen, and after this will be shifted here actually. So we will get here uh, two electrons, or we can say negative charge. It have a bromine. Okay. Now this one, mm, I think I will get water. Okay. Now anyhow, now come to again our reactant RC double bond O, and here nitrogen having a negative charge. Just remember, negative charge for nitrogen, and it is called here. Actually, this one is called N bromamide. Brom bromamide bromamide ion. This is we are calling as degradation of bromamide. Actually, degradation of bromamide means from here we are going to separate degraded. It means we are going to separate this carbonyl group actually. So now what happens here? So this will be shifted here. Okay, so it will be shifted here, and this will be bonded here actually. So what happens actually here? You see here, one more time R, and we have carbon double bond and nitrogen having here. Solid has two lone pairs actually. So now after shifting here, okay, after I'm writing after losing this Br minus actually. Okay. Okay, as we know already there are two electrons are there upon nitrogen. Now this will be shifted here. This will be shifted here so that it will get a positive charge. So what I'm saying, this electron will be shifted and to make a double bond with this carbon. So because of shifting, it is going to get a positive charge. And this alkyl group will be there. This alkyl group will be attached to the shifted to the from carbonyl group to the nitrogen group. Okay, na? So now as a result it forms. So let me write nitrogen first, and for the nitrogen there is an R is attached here. With nitrogen now we have double bond is formed here. Double bond is formed. We have carbon. So carbon also have a double bond. Okay, this is called as isocyanate. Isocyanate they will call alkyl isocyanate they will call. So now for this one what happens actually, this double bond will be shifted upon this oxygen, so it forms R. So let me write again here. We have R and nitrogen, double bond carbon, and double bond oxygen. Now this electron is shifted here, so it forms. It will write here better. Okay. Now see for this carbon we have single bond oxygen and electron is shifted here. Okay, na? So now for this one, if we added the water, what else we can say? To add water here, this water, this will be okay. Now I think this will be shifted here. So after shifting here, this carbon will get a positive charge, right? And here what I'm saying, these electrons are shifting over the oxygen, becomes oxide ion. And now this is carrying a positive charge. That's why this nucleophile attack this carbon. Okay. So what happens here? So we'll get here R, nitrogen, and double bond O carbon, double bond carbon. Okay, we have carbon here, and here we have O minus, and this will be attack here. We have oxygen, and we have here hydrogen. Now what happens actually? So now this bond will be shifted here, and this will be shifted here. I think so. Okay, shifted here to get a positive charge. Let me write here. So it forms R. So nitrogen will be carrying this electrons here, and here carbon it becomes double bond O, and here O minus, and this hydrogen will be shifted here. I mean it will attach to the this nitrogen, so it will form a bond here. Okay, so later after addition of water, so we are going to add water here. Okay, so now what we can write here, and this will be shifted here, and this will be shifted over nitrogen, so it forms R, nitrogen having here electrons. Okay, carrying a negative charge. It will attack by this. It will attack the hydrogen actually. So after addition of water, it forms RNH2. RNH2. Okay, so if you want, you can remove this voice number. So this is how we got the primary amine. Primary amine we got. Okay. Now in this case, you remember isocyanate ion is going to form here, and here we have alkyl groups, and then we have alkyl group bonded to the nitrogen, nitrogen bonded to the carbonyl group. This is why it's called isocyanate. If it is reverse, it is called cyanate. Similarly here, understand here why it is called a degradation of bromamide. So this ion will be there, no? So this ion, especially this ion is called bromamide. Bromamide. Bromamide they will call. So this one we are going to make separation, decomposition means degradation of this carbonyl we are going to remove. So you can see here. So alkyl group is shifting. Alkyl group is shifting from, see here, it is shifting here. Nitrogen, this alkyl group, you can see here, there is an R. Just a second. Here you can see here, this alkyl group is shifting from, it attached to the carbonyl group and later it is going to shift. It is also called 1-2 shift. It is also called 1-2 shift. So these are the points, key points we are supposed to remember. Okay. So I hope you found the video useful. Thank you for watching. Thank you for watching. Okay. Please do subscribe, share. Thank you.